Yeah, so maybe we can. All right. Check. Mm, okay. All right, so I think we can yeah, continue with our discussion. Yes, so last meeting we uh, began talking about the Cartesian coordinate system. And so we'll be using this in many ways in our different topics in algebra. Okay, so we said that in a Cartesian coordinate system, we definitely have the coordinates, of course, the x and the y coordinates. All right, now, but before I proceed with more graphing, let us first discuss on, how to just a simple looking for distance between 2 points along the x-axis. Yes, and definitely that's very much counting in a way, because like if I want us to look for the distance, I will now have this the x-axis. Okay, let me use my laser pointer. Okay. If we now look at the distance between D and F, all right, so knowing that the D along the x-axis is -2, and and as far as the F point is concerned, and that is 3. So counting the distance between D and F would be 5 units. But maybe we should not really just count, but we can use a mathematical operation to be able to find the distance between -2 and 5. And -2 and 3, I should say. And that's actually just subtracting, from 0 to 3 is 3 units, and from 0 to -2 is 2 units. And so one way of doing it is you just say it's actually, it's a 3 minus 2, which is equal to 3 plus 2, 4 is equal to 5. Yeah. So it's just subtracting, the point, from the first point to the second point. Well, similarly with vertical axis, we now have the point from the point -4 to +3. And, we can just count, but that's the same as 3 minus 4, which is equal to 7. So that's actually finding the distance. But one thing with the distance is you are not very much, focused on the sign or the direction. It is more of the magnitude. Because there would be times when I would say, what is the distance? The point is moving from the top to the bottom, all right? Or from the right to the left. And so you say the movement is from 3 to -2. And so if you would consider -2 as the last point, all right? In other words, you're saying the -2 is your x sub 2. We now talk about x sub 1 and x sub 2. If your x sub 2 is -2, because that's where you moved from +3, then actually the distance is looking for x sub 2 minus x sub 1. All right, because it's from the point where you landed okay, minus the point where you started. And so if you will be using that, that should have been minus 2 minus 3, which is equal to minus 5. But as I was saying, when you deal with the distance, you just want the magnitude. It's not about this is not a vector. We call it vector quantity in physics. It is a scalar saying that you're just dealing with the magnitude. So you're not interested with the sign. And in such case, you remember this symbol, all right? The bar like this. Yes. What is that symbol when I have anyone who remembers the
Value.
what do we call
Uh,
it? All right. We actually
absolute.
call it as the absolute value. All right. So we call it absolute value. Yes. So that's what we would be dealing with when we are dealing with the distance from the point to zero. We're now talking about, or from any 2 points, we will be dealing with the absolute value of of the number, because the number, I mean the distance is really very much into how much had been, I mean the length of movement. Mhm. So the distance, which is the absolute value, is always positive or zero. Yeah, absolute value can never be negative. We'll talk more about absolute value in our discussion in future, but that's what's important to understand when we're dealing with distance. All right. Now, when we graph the absolute value of a number, okay, just suppose, so we now have this function, all right, or this is the equation for the absolute value. Y is equal to the absolute value of X. The fact that it is never negative, all right, along, so when we now move, if Y is equal to 1, then the absolute value, I mean, if X is equal to 1, the absolute value of X is of course equal to 1. If Y is equal to X is equal to -1, the absolute value of X will also be +1. So in a situation like that, then our graph on the Cartesian coordinate system, it won't go below the value of Y will never be negative. It will always be positive. So for any value of X, it will be negative x's would be positive x's would also be positive x, but at the same time, there's also zero. So that's the absolute value. So more about absolute value functions later on in our discussion, but at the moment, that's just, reminding us of what absolute value is all about. And so now we will learn, yeah, because we're now dealing with distance. Besides distance, between points along the x or points along the y. It's also good to know the distance between one point in the Cartesian coordinate system to another point, all right? From one point to another. And so we will make use of our Pythagorean theorem in order to find the distance formula. All right, so this distance formula, so between 2 points in the plane, x sub 1, y sub 1, and x sub 2, y sub 2. And so you remember your Pythagorean theorem. According to the Pythagorean theorem, if you have a right triangle, the distance of, or the length of the hypotenuse, this is our hypotenuse, all right, will be equal to the length, the square of the length of one side, which we would be considering maybe the horizontal side, and the square of the length of the vertical side of the right triangle. So the distance, of course, between point 1, x sub 1 to x sub 2 will be the absolute value of x sub 2 minus x sub 1. But then we'll have to square that. And then the distance between y sub 2, okay, and y sub 1 will be the absolute value of y sub 2 minus y sub 1. And therefore, with our, okay, this is actually the formula for Pythagorean theorem. All right, if you remember that, C is equal to A squared plus B squared. So that if A is x sub 2 minus x sub 1. I'll not put absolute value anymore in the formula. Reason is because anyway you're squaring, all right? So you're squaring. So we square the distance between x sub 2 and x sub 1 along the x-axis, and we square the distance between y sub 2 and y sub 1 along the y-axis, and then get the square root. So that's always the formula to find the distance between 2 points in a plane. So with that formula, we will be, so like, just suppose I have two points, -3, -1, and 2, 3. What is the distance between these points, -3, -1, and -2, 3? Right. So let's do that. So let's begin with the excess. All right. So anyway, here, it's not a problem whether you begin with x sub 2 minus x sub 1 or x sub 1 minus x sub 2. But for order, would consider this, of course, as our point 1. This is our point 2. Yeah. So therefore, our x sub 2 minus x sub 1 will be equal to this one will be the excess. All right? 2 minus 3, right? Which is equal to 5. Your y sub 2 minus y sub 1 will be, this is now our -1 and 3. So that will now be 3 minus -1, which gives you 4, right? And so, substituting to our formula, your x sub 2 minus x sub 1 is 5 squared. Your y sub 2 minus y sub 1 is 4 squared. So that will now be the square root of 25. 25 plus 16. All right. 5 times 5 is 25. 4 times 4. That will now be the square root of 41. Leave it as it is. Of course, you can extract the root using your calculator, but it may not be necessary. All right. It's in our discussion here. If it is not a perfect square, leave it under the radical sign. Okay. So that's just it. 2 minus -3 is 5. 3 minus -1 is 4. And then you just square and add, and that's under the radical sign. Yes, so that's distance formula. Okay, will you please do number 2?
Do you need to see the substitution? Like the ones that you wrote on the side?
No,
X.
yeah, you can, if you want the mental math, that's okay. Or maybe why don't you do mental number 2, 1, 4, and 11, 9. That's not a problem for me, as long as I know that you have. Just be very careful, because sometimes we write a wrong number, even if in our mind that's the number, but we write it differently. Okay. So doing mental math, what would say? Just to put the x sub 2, x sub 1 squared. What is x sub 2 minus x sub 1?
10 squared plus
All
5
right,
squared.
so that's 10 squared plus
5 squared.
Okay. Yeah, 9 minus 4. So it's just a matter of subtracting 11 minus 1, 9 minus 4. Okay, and final answer?
100 minus 25 is what?
Square
Plus
root of 125.
25.
All
100.
right. Now, can you still simplify, remembering what we have done previously?
Yeah. Yep. Because we have a root of 125.
What will be, how would you simplify?
25 times 5.
All right. So 125 is 25 times 5, right? And the square root of
Yep.
25 is
5.
5. The square root of 5. So if it's yeah, if there's a perfect square as one of the factors of the one that you have in the radical sign, then please do that. So then your final answer will be 5, the square root of 5. Yes, so what we have learned previously, we will be applying and dealing with roots. Okay, that's distance formula. So I think that's something that, yeah. Well, one nice thing about this distance formula, all right, or even the Cartesian coordinate system, it's being used in the map, all right, finding distances between points, like how far are you from me? From you look, Google, I would say from Heartland College in West Virginia to my home in Riverside, and then you would look for that distance. All right. Okay. So in the map having coordinates, we are actually making use of our Cartesian coordinate system, except that really, you know that the world is round, but they have done some grid and make it a little bit like a rectangular coordinate system. So that's what it is in a map. We now have what we call the latitude and the longitude. And of course, our latitude is our x-axis. Our longitude is the y-axis. All right. And the zero degree longitude is a prime meridian, and the equator is a 0 degree latitude. And so that's how it is. Yeah, I remember when we were in Kenya, there is a place there that's because Africa, just very close to the equator. But in Kenya, there is a place there where that is really the equator. And every time we pass by there, we just when we bring visitors, we just go down and would take picture and would say, now this one is the we are now on the equator. All right. So that's how it is. And of course, even Asia, very close to the equator. So even when we deal with directions, when we now talk about the east, the west, north, and south, it is also the rectangular coordinate system, where the east is the positive x-axis, the west is the negative x-axis, the north is the positive y-axis, and the south would be the negative y-axis. So now, as I was saying, they're using this in order to find distances between points in a between locations, right? And so they just decided to make it like it's not really a plane because it is a sphere kind of thing, but that's the way they're doing that. So in a situation where, well, I just looked at the map of northern, this one is Northern California, and looked for, and of course, our book has given us some coordinates of the locations of Sacramento and San Jose. All right. So you would, okay, you would see that, this one is Sacramento and this is San Jose. All right. So if you know the coordinates on a map, well, maybe that's difficult to imagine because, as I was saying, we're looking at it as a plane, but this one is not really a plane because it moves this way. But anyway, the coordinates on a map for Sacramento is 128.78, and those for San Jose, California, would be 76 minus 12. So those coordinates would be representing the mile. That's from the origin, all right, from the origin. So we want to find the distance between Sacramento and San Jose. Will you please do that for me now? Yes. Knowing the coordinates, look for the distance between Sacramento and San Jose. And maybe we can really extract the root because, it is real life. So it's good to know how many miles between San Jose, Sacramento, and San Jose.
Which one is on the east? Which one is on the west? What did it say? 72.1.
Mm.
It's gonna be -1.
If you,
What is the absolute value rate?
if you square a
Mhm.
negative number. On
How many? You find now the distance?
Can we use calculator?
Yes, yes. It's good to use the calculator because yeah, and extract the root so that we would see the estimated number of miles. Okay, maybe you can just round it off to the nearest whole number to look for how many miles would be the distance. Okay. So the x sub 2 minus x sub 1, yeah, we can just begin with the 128 minus 76. So 128 minus 76 gives you 52, right? Then
Yes.
78 minus 12. Okay. So that would be, is that 90?
Yes.
Okay. So the square root of 25 plus 8100. 50, I'm sorry about that. That's 52. 128. Sorry, 52 squared. Why did I put? Okay, let me erase it. Tell you. Okay. So that's 52. Okay. So we now have D is equal to the square root of 52 squared plus 90 squared. And 52 squared is
2,704. 04.
2704, all right. And 90 squared is 8100. Adding, then you get the square root
Together,
of 10,804.
and it's 103.94.
All right, 103.94 is approximately about 104 miles away. So Sacramento, CA, and is 104 miles away from San Jose. So that's one application of our rectangular coordinate system. It's just been used in the mapping and looking for distances. Yes. Distance formula. Well, I would another because we will be using some of these in our problem solving when we want real world applications. So we'll talk about the midpoint formula. Yes, I think you are very much. So when you have now endpoints of a line segment. So when we now talk of a line, we're talking of infinite from the left to the right. But when it's just a certain portion of a line, of a number line, then we call this the line segment. So the line segment, and we want to find the midpoint. And so just getting the point, it's dividing, the distance between the x coordinates by 2 and dividing the distance, okay, between the coordinates, that length, y sub 1 and y sub 2. So if you are given the midpoints, the endpoints of a line, x sub 1, y sub 1, and x sub 2, y sub 2, you just get, because the reason why it is a plus is because this x sub 2 is actually the distance, this from this point to this, yeah, this This is your distance. Okay, let me make that red so that it's easy for you to see. Okay, so the x sub 1 is actually this distance from the origin, okay, from this point. The distance of y sub of x sub 2 is this length, that length. So that's the reason why we're getting add the 2 and divide by 2. Okay? Because x sub 1 is from the x-axis to the point, or the x sub 1, the y, I'm talking about the y, while the x sub 1 is this point, and for the other one is, yeah, this is the x from 0, no, that's the idea. So x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. So that's our midpoint formula, right? Okay, so given the endpoints, just, you can do that mental math. What's the midpoint between the line segment 7, -2, and 9, 5?
Eight.
Okay, that will now be, so the midpoint will also be a coordinates, an ordered pair, So along the x-axis of 7 plus 9 divided by 2 is 8. So 16 divided by 2, and then minus
3
2
by
plus
2.
5 is 3, right? Minus 2 plus 5. So you're adding, you're not subtracting, you're adding. Minus 2 plus
Oh.
5 is 3 divided by 2. You can put it as 1.5, or you can just say it's 3/2. It's okay. So it's 7 plus 9 over 2. This is 16 over 2 and 8. That is now
Mm.
minus 2 plus 5 over 2. That is 3 over 2, or 1.5, if you want that to be 1.5. So you're adding the coordinates and divide by 2, specific coordinate x or y. All right, number 2, what would be the midpoint between -2, -1, and -8, 6?
Minus
Minus
5.
5 and 5 over 2
I can't see.
and 5 over 2
Yes.
minus
So minus 5 and
5 over 2
5.
2.5.
Okay, 5.
2.5.
So 6 minus 1 minus 8 minus 2 is minus 10 divided by 2. So then 6 minus 1 divided by 2. So those are. So we'll go back to this later on when we would have some problems that would involve the use of looking for the midpoints, right? And this one will be the midpoint formula. All right. So just reminding us of what we did last time. Actually, we said that when you graph equations into variables, that means there's an x and a y. But we mentioned that in y is equal to 2x minus 1, your y is called the dependent variable, and your x is the independent variable. It's the x that you will have to put in values of x, and the value of y would depend upon the value of x. So the elementary way is try to substitute values and then look for those, as we have shown last meeting. Yes, I just want to remind us, okay, after getting all those numbered ordered pairs, when we substitute from -3 to +3 of your x, then we got a straight line. So just points, okay? Plot the points and draw a straight line. But I think we learned that we would be talking, we have learned about what we call the intercepts. All right, you remember the intercepts, and the intercept, okay, let me go back, would be the point, all right, where the graph passes the x-axis, that's your x-intercept, and of course the y-intercept is the point where the graph passes the y-axis. And according to geometry, it's not necessary to have so many points to draw a line. As long as you have 2 points there will always be one line that contains both points. All right. So for any 2 points, there is exactly one line that contains them both. Right. So if I have an equation, y is equal to minus 2x plus 4, I will just have to look for the points where the graph passes the x-axis. I mean, where it is now a 0, a 2, 0. If I put in all those points, when x is equal to 2, your y is equal to 0. So this one is our x, all right. But when x is equal to 0, your y is equal to 4. So that having only 2 points, you will already be able to graph your linear equation. So we have learned about that last meeting. Okay, so now let's proceed with learning how to use intercepts. You use intercepts in order to um, graph the line. But I just want to remind us, because now we will be solving equations, all right? We are looking at a function. Of course, right now we're just dealing with a linear equation. Okay. So reminder of the properties of equality. Okay, so some of these terminologies are important to remember. There is such a thing as what we call reflective property. Okay, and so the reflexive, I should say, the reflexive property means that A is equal to itself. That one is just a simple thing. All right, you are equal to yourself. Okay, A is equal to A. Then there's such a thing as symmetric property, where if A is equal to B, B is equal to A. So yeah, because they are equal, therefore, even if you interchange the position of A and B, all right, that will also, they are still be equal. So just for illustration, we would say if 1/2 is equal to 2/4, I think you know that 1/2 is equal to 2/4. Yes. So I can interchange the position. I can also say 2/4 is equal to 1/2. Right? That's the idea. Then it says if A is equal to B and B is equal to C, then A is equal to C. So if you say if 1/2 is equal to 2/4 and 2/4 is equal to 3/6, okay? It's one half, right? Yes. So if they are the same, then that means that 1/2 will also be equal to 3/6. Divide by 1, divide by 3. Yeah. So that's transitive. Then there's another property which says if A is equal to B, you add a C to A and you add that same constant to B, then the equation will still be balanced. In other words, the only way that you are able to balance the equation by addition is to add to both sides the same constant. Similarly, subtraction, for A and B to be balanced and you want to do subtraction, all right? What you subtract on one side will be the same value that you should subtract on the other side, so that they will still be balanced. And when you multiply, you just multiply the same constant, that will still be A is equal to B. And if A is equal to B, you divide by the same constant, to A will still be equal to B. And it says if A is equal to, that is substitution, which we will be using in many of our problems, especially on equations. If A is equal to B, then B can replace A in any expression. So if two values are equal, you can substitute that same value in any algebraic expression. All right, so you will be seeing the use of these different properties of equality. But it's just interesting that especially for addition, subtraction, multiplication, and division, yeah, I would say that is actually the golden rule of algebra. If you have a golden rule in life, what you would want others to do to you, do the same to them, something like that. So the golden rule of algebra is that what you do on one side of the equation, you must also do on the other side of the equation. So that is being fair, being just. All right, that's the golden rule of algebra. And so I just would want to get a Bible verse and from Proverbs 1:3, the 1984 edition of the New International Version. I just love this translation here. And it says, for acquiring a disciplined and prudent life. And I would like to say that when your life is disciplined and prudent, then that is a balanced life, doing what is right and just and fair. So to acquire a disciplined and prudent life or balanced life, we need to do what is right and just and fair. And that is the golden rule. All right. What you do to others, what you want others to do to you, do the same to the others. And what you don't want others to do to you, don't do that to others. So please remember this golden rule of algebra as we solve equations. Right. So now I think I showed this last meeting, and we have the definition of intercept, the x as well as the y-intercept. So for us to be able to look for the x-intercept and the y-intercept. So to solve for the x-intercept, we just set y is equal to 0. So for the equation y is equal to 2x minus 4, put 0 instead of y, okay? And solve for x. And so now here we are using the substitution, I mean the subtraction uh, property of equality. So for us, we want our 4 here, okay, to be 0 so that we will be left with x. Okay. So we just add for 4 to be 0, we subtract 4. But what you do on one side, you do to the other side. That is the principle. But I think you already know that you want to do some shortcuts. So you don't even want to do this part anymore. So you just immediately transfer 4 to the other side. But if you transfer 4 to the other side, my algebra teacher was saying, when it passes the bridge, which is equality, change the sign, all right, of your value. So you have now 2x plus minus 2x plus 4 is equal to 0. I can put that way because we call that transitive kind of thing. All right. So we now say transfer to the other side, then you move to this. Okay. So minus 2x is equal to minus 4. And of course, divide by negative 2. That's another property, which is on division. So you divide negative 2 over negative 2 so that you'll get x. What you do on one side, do to the other side. Minus 4 divided by 2. Minus 2 is equal to 2. So therefore, x is equal to 2. So 2 is equal to x is the same as x is equal to 2. So it's some of those properties of equality. And therefore, our x-coordinate would be 2, 0. So take note that the x-coordinate is x, 0. And the y-coordinate is 0, y. So this one is our x-intercept. If that is 2, 0. So this is 2, 0. And so just the same, to solve for the y-intercept, let x is equal to 0. So if x is equal to 0, y is equal to minus 2 times 0 is equal to 0 plus 4. So your y-coordinate for the y-intercept is 0, 4. And so it's from 0 to 4 if ever this one is a 4, whatever it is. Yeah, but you can make that in the Cartesian coordinate axis. And so knowing, all right, 2 points, you just connect and you'll be able to get the graph. All right, so it is just a review of what we have talked about. So yeah, so similarly with this, okay, so that one I already showed. This one is our y-intercept. Reason is because if x is equal to 0, y is equal to -1. Now, if y is equal to 0, what will be x?
Y is 0. X will be 1/2.
All right. So you'll now have 0 is equal to 2x minus 1. So you now have 2x is equal to 1. x is equal to 1/2. Very good. All right. And this is now the 1/2. Okay? This is now your -1. So we don't need all those points. We only need the point 1, 0, and we only need the point 0, -1, and you can just connect. Because as a reminder, we're saying that at any 2 points, through any 2 points, there exists exactly one line. Okay. So knowing the intercepts, you don't need to do all those points. You can just you can just draw the line. Okay. Right. So I think that one had already been done. Okay, let's try. Yeah, just sketching. Please sketch y is equal to x plus 4. So maybe this time you need to, so that you don't do a lot of putting x, y axis. Maybe I hope your notebook is a math notebook with graphing, graphing thing. Yeah.
Wait, so
So are they two different problems? Are there two
Yeah,
different
two different
points or graphs?
problems. Okay, you begin with this first, okay? Y is equal to x plus 4.
Y is equals to 4, x is equals to -4.
All right, and graph that now. You draw the graph. All right, so you're now saying your the coordinates would be, for the x coordinate is y 0. If y is okay, it is now -4, 0, and 0, 4. So if y is 0, x is equal to -4. Yeah. So 0 is equal to x plus 4. Most of the time, it's easy to look for the y-intercept, because you just make x 0 and then you'll have your y. But for the x-intercept, you just have to follow the principle. So then x is equal to -4. All right, so I think you have done that now. So -4, 0. This is the point, right? And then 0, positive 4. And then connect. Let me connect. I hope I can have a good straight line. All right. And but you can extend that. All right. That's the line. Oops. Good. All right. The second one.
Can I please ask a question?
Yes?
Is it necessary for us to put all the numbers on the Cartesian plane? Or we just say, we assume, okay, 4 is here and 4 is here. And
Yeah,
then
as long as you are good. I mean, make sure that you have equal that, what would I say? You have equal. Yeah, do not just put anywhere. All right. You don't have to put 1, 2, 3, 4, 5, and so on. But what I'm just saying is, make sure that 1, 2, 3, 4, they have the same distance, but from 1 to 2 to 3 to 4, like that. Yeah. So
yes,
yeah,
I mean,
yeah, if you can count. You know what I'm saying is, you can 1, 2, you may not put any more, -1, -2, -3, -4. No problem. That would be fine. Okay? So you just say, well, after knowing that this is 1, 2, 3, 4, put the point there. All right. Then you now have 1, 2, 3, 4, put the point there.
Oh.
Yeah. No worries. All right. Let's have now the
why is it this? 0
I
and
do
3.
the second one.
0 and 3. Why is 3
Okay.
and
So you now have 0, 3 for your y coordinates.
And then x coordinate is.
I remember I used to solve this by the slope formula.
Well, yeah, we'll go to that. This one we are just graphing, okay? We're graphing, okay? Then later on we will know what is the slope and because the 3 is your y-intercept. Okay. But of course, you'll have to look for your x-intercept. Yeah, so you have now minus 3 over 4x is plus 3 is equal to 0, right? Because you set y is equal to 0 and solve for x. So you first transfer, okay? Minus 3 over 4x is equal to minus 3, right? You transfer to the other side. Okay.
Yes.
Yes, so what do?
You times. You
You multiply both sides by so that you will remove your 3 minus 3/4. You multiply by its reciprocal, you remember? So you multiply by minus 4/3. But you can do more if you already know why it is so. What you can do is just you say minus 3x is equal to multiply this. Negative 12, right? Are you
and
good?
then you divide.
Yes, and you
Divided
divide
by-
this by minus 3, divide this by minus 3, then you get your x to be positive 4.
But you can also take the 3/4, like 3 over 4 times the 3, and then the answer will be 4 because 3 and 3.
Okay, yeah. Some of you may decide to just cancel 3 and 3 and then cross multiply by 4. That's okay. So as long as you know that the principle is the same. Okay.
Yeah, I can't.
Okay, let's do that again. Okay, let me erase all the ink here. No, not all because I'll erase this only. Yeah, we are now where is how come my eraser is not good? Okay, erase. All right, I'm erasing this now. All right. So I'm saying minus 3x over 4 is the same as 3x divided by 4. Okay. So when you now have minus 3 over 4x, that is the same as minus 3x over 4. If you remember, that's the same. So that the 3x can be with the 3 rather than I would put that as a coefficient that minus 3/4 is the coefficient. So that's actually minus 3x over 4 plus 3 is equal to 0. So it's always good to have the x isolated on the left side and transfer the constant to the other side. So that's why we say minus 3x over 4 is equal to minus 3. So actually, what is the principle is saying, we multiply this by minus 4 over 3 so that will become x. I also multiply this by minus 4 over 3 and minus 3 and 3 will cancel. Minus is equal to 4. But another way of doing is, yeah, you just cross multiply. I hope you remember that one. Some teachers would talk about that as a cross multiplication, where you now have minus 3x over 4 is equal to minus 3. Then multiply 4 times negative 3. That's what I did here. So 4 times negative 3 is negative 12. Then you divide by 3, you'll get x is equal to 4. Is that okay? So therefore, our coordinate for the x coordinate, that will now be equal to 4, 0. Then you now graph. So this one is 4, 0. And then I have, what's your y coordinate is 0, 3. There. Right? This one. So the line is this. As I said, I am not very good in making a straight line. Okay. Imagine that that's straight. Even if it is not. So in your paper, make it straight. All right. So that's how to sketch the graph using intercepts. Yeah, so we'll have more of this. So you notice that the graph can be rising to the right, or the graph can be rising to the left. And as mentioned by Manesh, she was talking about the slope intercept. We will be talking about the slope, all right? But not now. We are almost, yes, we just have 3 minutes to go. So any question on the intercepts done? So next meeting, we will move on. We'll be dealing with slope. We will be given an equation. We will be able to look for the slope and the intercept, or given some points, we can look for the equation of the line. So we are now into equations. So please be reminded, just always remember all those properties of equality. And then knowing those, we can just, share with each other some shortcuts that we know, all right? So that we don't do a lot of steps in the process of solving the problem. Okay, so I think that will be all for today. So we'll now, so just before you even go, we have a few, just 2 minutes more. In my course syllabus, supposed to be on Thursday, that's the 1st of February. Wow, imagine, no more, January is gone, all right? On Thursday, it's already February. It's supposed to be, it's our midterm exam, but I will have to move, okay, so that you can look forward. The only reason why I want to give a midterm is I want to divide the exam into 2 equal parts, rather than have the final exam, and so, have the final exam all through. We better just have half and half. So we will plan, and we'll have our midterms, and of course I'll give you a review guide, all right, so that you don't get overwhelmed on Tuesday next week. So we will still continue with our discussion on Thursday regarding the equations, or the linear equations, which will be part of your midterms. So that will be all for today. Okay. And let me now stop the recording. All right. Have a blessed